Today's video is on relations, functions, all that good stuff. So a relation can be written as a graph. It could be written as a mapping. It could be written as an equation, or it could be written as a table. I think the one that you're not too familiar with is a mapping. A mapping is when you have the domain in a bubble and the range in a bubble, and you list them in least to greatest, and you kind of draw arrows mapping them from the input to the output. The set of x values is called the domain, as you know, and the set of y values is called the range. A relation that just has dots with just points is called discrete, a scatter plot. A relation with connected lines or even curves is called a continuous function. So you can either be discrete or continuous, and we'll talk about other functions later on. Let's scroll down a little bit. Identify whether a relation is a function or not. So functions can't repeat domain values. There can only be one x. So a function could look like 1, 2, and then the next point, let's say 5, 8, and then the next point, let's say 3, negative 2. The x values here do not repeat. At 1, 5, and 3, all different. Also, what is not a function, if the x values do repeat, let's say we have 2, 8, so we have 3, 7, but then again we have 2, negative 1. That is not a function because these 2's repeated. It's okay if the y's repeat, but the domains cannot repeat. Another way to check to see if a graph is a function or not is through what's called the vertical line test. So a normal function, it's a continuous, just looks like that. Or it could look like discrete, where you have dots everywhere, just like that. But not a function looks like this, where if we take a vertical line and we draw it through the graph, it's going to pass the graph at 2 points or even more. So this is not a function because a vertical line passed through the graph more than once. You can even fail through a discrete function. So let's say here's my graph, but then I have another dot right here, right on top of this dot. So vertical line test shows that it fails right there. So this is not a function in this case because we have, again, we're repeating domains, we're repeating x's, and this fails the vertical line test. Through this page pretty quickly, so try to keep up. This should be a lot of review. Domain of number 1 is squiggly bracket, the set of all the x's, and I'm going to list them least to greatest. They're already listed, kind of, least to greatest, but awesome. Range is the y's, these, and I'm going to list them as well, least to greatest. Perfect. And is it a function? Are any of the x's repeating? No. So you have -1, 0, 4, 6. Since it's not repeating, it's okay. It is a function. Let's move down to a little more challenging stuff, which talks about domain and range of some graphs. So on this discrete graph, we have a bunch of ordered pairs. We can find the domain just by looking at the x's. So 1, 2, -3, there is a point. 0, there's a point, and also at 2, there's a dot. If it repeats, and there's multiple points at like -3, just write -3 once. For the range, you're looking at the y's, and you're going lowest to highest. Actually, I think I forgot one for the domain. There was one hiding all the way in the corner, right here. So that is 1, 2, 3, 4. Good catch, Mr. Kalman. Okay. So now for the range, we go lowest to highest. The lowest is 1, 2, 3, 4, -5. And again, we're looking at the y-axis for the range. The next lowest is -2. The next lowest is -1. Then we have one at 1. And then we have one at 4, I believe. So -5 was the lowest. Then we had one at -2, -1, 1, and 4. Is it a function? I talked about this a little bit before. It is not a function because these 2 points right here, when you're drawing a vertical line on top, they fail vertical line test, they repeat. Let's look at more of a linear continuous graph, number 8. In number 8, let's check out the domain and range. The domain, you check out the x-axis left to right. So it goes on forever and infinity and negative infinity in both directions. The way we write that looks like this with the parentheses. And then for the range, we look at the y-axis going down to up. So this graph here goes on forever in both directions. So technically it does go down forever and up forever along that blue y-axis. So your answer for the range is also negative infinity to positive infinity. It does pass the vertical line test because no matter how many vertical lines I draw, I'm only going to pass through the graph once. So it is a function. Let's look at some weirder graphs. Number 9, let's look at the domain from left to right along, again, this x-axis. It starts at 1, 2, 3, negative 4. But since it's a closed circle right here on the graph at negative 4, we're going to put a bracket. And then it goes on forever in these directions. So it goes on to infinity with the parenthesis. The range goes lowest to highest. We're going to do it along the y-axis. So the lowest the graph goes is all the way down here at negative infinity. And then the highest the graph goes, all the way on top, is positive infinity with another parenthesis. Does it pass the vertical line test? Is it a function? Here, I'm drawing vertical lines right here, here, here. It does not pass, so therefore it is not a function. Write down what questions you guys have so far on domain and range of tables and graphs. The notes is just substitution called function notation. In function notation, you have x is the input and y is the output. So in this case, let's look at our example. If f of x is 2x plus 7, find f of negative 3. Function notation is just a fancy way of writing y. So instead of writing y, I'm going to write f of x. So whenever you see f of x, if you want, you could change it to y. But what the number in parentheses means right here is your x, right here. You're going to take negative 3 and you're going to plug it in for x. Doing that, plugging it in for parentheses, we get y equal to 2 times negative 3, which is negative 6 plus 7 is a positive 1. So all we're doing is substituting the number or quantity in parentheses for x to figure out your output value. Let's do a couple examples real quick. Number 4, we're plugging negative 7 in for the g function. So here's the g function. And whenever I see negative 7 in for the x, which is right here and right here, I'm going to put in parentheses negative 7. So we have negative parenthesis negative 7. This was a big mistake that you guys have been making with the negative on the outside. Plus 9 parenthesis negative 7 minus 1. Negative 49 minus 63 minus 1. Keep simplifying. Believe you get negative 113 as your final answer after plugging negative 7 in for all the x's in the g function. And it'll always tell you, whether you're doing the f or the g, so no need to worry about that. Let's look at number 6. Looks a little different. In number 6, what it says is we're going to take 12, and since it's in parentheses, we're going to take that and put it in for the g function. Let's do that. And then after we found out what that answer is, we're then going to multiply it by 2. So we got negative 144 plus 8 minus 1. Let's keep going left to right with our addition and subtraction. Negative 144 plus 108 is 36, I believe. Negative 36. Subtracting 1, you get negative 37. After we get that, we're going to times that quantity by 2, and we will get negative 74. Let me know what questions you guys have on plugging in the number and then multiplying. Next page, this is the last one we're going to do for today's video. Let's do number 13. It's a little different because here there's no number in the parentheses. Instead, they gave us the output. So f of x is 3x plus 19, but we're going to have to find x. So we don't know the x, but we do know the f of x part. They said that's 34. So here we substitute that in for technically the y output, and then all we do is solve. So minus 19, minus 19, so we have 3x equaling 15. Dividing by 3, x is going to be 5. So not too hard of a problem here. If you want to try some more practice problems on these pages, you can. We're going to go over some more of these notes tomorrow real quick before we do our activity. Have a great night, guys. See you guys next time.